Right now, somewhere in northern Germany, a car just rolled off an assembly line. And before you finish that sentence, another one will too. One every 16 seconds, 24 hours a day, 365 days a year. The Wolfsburg factory is the most relentless industrial machine ever built by human hands. And there is a story behind it that almost nobody knows. Not just the story of how a car gets built, though that alone will leave you stunned. The story of how a factory city was conjured out of nothing, on the flat floodplain of the river Aller, by one of the darkest regimes in human history. The story of how a promise was made to millions of ordinary people and then deliberately broken. And the story of how, out of all that, slavery, ruin, and shame, there emerged something that would become the industrial backbone of an entire country, and eventually the template for how cars are made everywhere on Earth. One car every 16 seconds. Let's figure out how that's even possible. Cast your mind back to 1938. Germany is under Adolf Hitler, and the Nazi regime has a vision. A people's car. Something cheap enough for every German family to own. They call it the KDF wagon, which stands for Kraft durch Freude. Strength through joy. Ferdinand Porsche, yes, that Porsche, designs the vehicle. Rounded, compact, and air-cooled. Clever engineering. And the Nazi government builds an entire factory to make it. From scratch, on empty land beside a canal in Lower Saxony. There was no city here before. No town. Not even a village of consequence. Wolfsburg, the city, did not exist. The factory came first, and the city grew up around it, built to house the workers who would supposedly fill the halls. On May 26, 1938, Adolf Hitler himself laid the foundation stone. Hundreds of thousands of Germans began paying into a savings scheme. 5 marks a week, faithfully deducted from their wages, with the promise that once they hit 990 marks, they'd get their KDF wagon. Over 300,000 people signed up. Not one of them ever received a car. Not a single civilian KDF wagon was ever delivered. When war broke out in 1939, the factory pivoted immediately to military production. Kübelwagen staff cars for the Wehrmacht, amphibious vehicles, aircraft parts. The savings? Gone. Absorbed by the state. The promise had always been, at some level, a fraud. A scheme to extract money from working people while making them feel like stakeholders in their own future. And then comes the chapter that Volkswagen spent decades refusing to confront directly. By the peak of the war, approximately 20,000 forced laborers were working inside this factory. Prisoners of war, concentration camp inmates, civilians dragged from occupied countries. At one point, forced laborers made up roughly 60% of the entire Wolfsburg workforce. And in 1944, a VW engineer made a personal journey to Auschwitz, to the extermination camp itself, to hand-select 300 Hungarian Jewish metal workers for transfer to the Wolfsburg plant. 300 people, chosen from the gates of a death camp to stamp metal parts for a car company. Volkswagen acknowledged this formally in 1999. A permanent memorial now stands inside the plant. The acknowledgement came late, as it often does, but it is there. After the war, the factory was a ruin. Bombed, stripped, barely standing. British Army officer Major Ivan Hurst took command, restarted production of the Beetle with military surplus parts, and refused the offer made by several American car companies to take the whole thing off their hands for free. Ford reportedly turned it down. So did General Motors. Nobody wanted it. Major Hurst kept going. By 1955, the 1 millionth Volkswagen Beetle had rolled off the line. By 1972, it had overtaken the Ford Model T as the best-selling car in history. All of that, every bit of it, traces back to this one flat piece of ground in Lower Saxony. Today, the Wolfsburg plant covers 1,600 acres. That is roughly 1.5 times the size of Central Park, packed with steel and machinery from edge to edge. The floor space inside the buildings alone runs to 17.2 million square feet. 46 miles of internal roads run through the campus. 37 miles of internal railway track. Nearly 62,000 people work here every single day, making it one of the largest single-employer sites on the planet. And alongside the production workers, 11,500 research and development engineers have offices on site. Right now, designing the next generation of electric vehicles, writing the code that will run autonomous systems, and figuring out how to build a car that plugs into the grid rather than pumping gasoline into a tank. Every 16 seconds. One car. Every single day. Now let's follow that car from the very beginning. Steel is where it starts, not finished steel. Raw coils, shipped in by barge along the Mittelland Canal that runs right alongside the plant. The canal is not an accident. When they chose this site in 1938, access to water freight was a deliberate engineering decision. Raw materials arrive by barge, get offloaded, and feed directly into the first stage of production. Every single day, The Wolfsburg stamping shop processes 2,600 metric tons of steel. 2,600 tons. Gone by midnight, replaced by the next shipment. And it is not one kind of steel. 36 different grades, each with specific tensile strength, specific thickness, specific elasticity, chosen for the exact panel or structural component it will become. The stamping shop is where a flat sheet of metal becomes the skeleton of a car door, a roof, a hood, a fender. Nothing will quite prepare you for the scale of it if you have never seen an industrial stamping press up close. The largest presses in this plant apply a force of 7,700 metric tons. Think about what that means. The Eiffel Tower weighs approximately 7,300 metric tons. These presses apply a force greater than the entire weight of the Eiffel Tower. And they do it over and over, every few seconds, around the clock. The Schuler MSP2000 transfer presses stamp outer door panels from steel that is just 0.8 of a millimeter thick, less than a credit card, at 18 strokes per minute. Press forces across the shop range from 50 metric tons at the light end all the way up to 7,800 metric tons at the heavy end. A single outer body panel takes seconds to form. What was a flat blank of metal becomes a compound curved door skin, precise to fractions of a millimeter, ready to be welded into place. Every 16 seconds, while you've been listening to this, the stamping shop has produced dozens more panels. The rhythm never stops. From stamping, the panels move into the body shop, called body in white in the industry, because the bare unpainted metal has a distinctive pale sheen. Here is where the car stops being a collection of flat parts and starts becoming a recognizable shape. Robotic arms, hundreds of them, position panels with sub-millimeter accuracy and hold them in place while welding systems fuse them together. The sheer volume of welding that happens on any given day is almost incomprehensible. Across the Wolfsburg facility, 89 miles of laser welding are performed every day. 89 miles. For scale, that is roughly the driving distance from New York City to Philadelphia, traced in a laser beam, across car bodies, every 24 hours. Each golf body alone carries approximately 231 feet of laser welds, 250 high-powered ND-YAG lasers, a type of solid-state laser precise enough for eye surgery, repurposed here for automotive manufacturing, run across the body shop continuously. Laser welding replaced spot welding in so many applications for one reason: strength. A laser weld penetrates the full thickness of the joint, creating a continuous seam rather than isolated connection points. The result is a body shell that is simultaneously lighter and stiffer than anything achievable with older welding methods. And here is where one of the most underappreciated engineering decisions in modern automotive history comes into play. Look at a Volkswagen Golf, then look at an Audi A3, then a Seat Leon, then a Skoda Octavia. From the outside, 4 completely different cars, from 4 different brands, aimed at 4 different buyers, sold at 4 different price points. But crawl underneath any of them, and you are looking at exactly the same front axle geometry, exactly the same pedal box positioning, exactly the same engine mounting points. All 4 run on the MQB platform, modular Querbaukasten, or modular transverse matrix, Volkswagen's master template for front-wheel drive and all-wheel drive vehicles. The Golf, the Tiguan, the Touran, the Passat, the Polo, the Audi A3, the Seat Leon, the Skoda Octavia. All of them, same bones. What that means in practice is staggering. When Volkswagen launched the Golf MK8 in 2019, 80% of the body shop tooling carried straight over from the MK7 without modification. Think about what that does to manufacturing cost. Every stamping die, every welding fixture, every robot arm position that does not need to change represents millions of dollars of tooling investment amortized across yet another generation of vehicles. And the average weight reduction versus the previous generation? 110 pounds per car. The MQB platform gets lighter and more capable with every iteration, while the cost to build it falls. Every 16 seconds, one of these bodies, Golf, Tiguan, take your pick, completes the body shop and moves to the single most technically demanding phase of the entire process, the paint shop. Most people think paint is paint, a color you spray on, a clear coat over the top, job done. The reality inside a modern automotive paint facility is so far removed from that assumption it belongs in a different conversation entirely. What happens to a VW body in the paint shop is a 4-stage process, each layer engineered to a specific depth and specific function, and the entire system hinges on a technique that borders on the counterintuitive. The first layer is called KTL, cathodic electrodeposition. The bare metal body is physically submerged in a tank of electrically charged paint. Because of the electrical differential between the charged liquid and the grounded body, paint deposits uniformly across every surface, not just the visible outer panels, but inside door cavities, inside the sills, inside every hollow structural section that a spray gun could never reach. KTL is what stops a car from rusting from the inside out. Without it, every hidden seam and box section would be bare metal, exposed to moisture, accelerating corrosion from within. The second layer is a filler primer, applied at 30 to 35 microns thick. Its job is chip resistance and UV protection, a buffer between the structural undercoat and the visible color layers above. The third layer is the base coat, 10 to 20 microns. That is where the color lives, where metallic flake gets suspended in the paint to catch light at different angles. The fourth and final layer is clear coat, 30 to 50 microns, a transparent shield against UV degradation, chemical attack, and environmental fallout. Add it all up. The total thickness of all four combined layers on a production Volkswagen is under 100 microns. 100 microns. A human hair is between 60 and 180 microns thick. Four discrete engineered layers, each serving a different function, and the whole stack is thinner than a human hair. And yet that film will protect the metal beneath it for 20 or 30 years in daily use. Not magic. Precision chemistry, applied at industrial scale. Every 16 seconds, another painted body comes out of the paint shop, glowing under inspection lights, ready to receive everything that will make it a car. The assembly halls where the factory's rhythm becomes most visible. Watch any time-lapse of a modern car plant and what strikes you is not the robots, it is the choreography. Cars move on overhead carriers, bodies suspended in the air while workers or robots install components from below. Engines arrive just in time from Salzgitter, gearboxes from Kassel, seats from suppliers within a 50-mile radius. 10 million individual components arrive at the plant every single day. 10 million parts, coordinated with enough precision that a component pulled from a truck at 6 a.m. is installed in a specific vehicle on a specific line positioned by 9 a.m. Any breakdown in that chain, any delay at a Tier 1 supplier, any traffic accident on the A39 Autobahn, ripples through the assembly line within hours. The moment everyone in the industry calls the marriage is when the body shell drops down onto the running gear, the platform carrying the engine, transmission, suspension, and wheels. On an MQB vehicle, the front subframe, carrying the engine and front suspension, must align with mounting points on the body to within fractions of a millimeter. Robots handle the initial positioning, but torque verification, confirming that every fastener is tightened to exact specification, runs through a digitally logged system that stamps a record against that car's unique identifier. Nothing gets missed, nothing is assumed. Interior trim follows: dashboard, seating, headliner, door cards, wiring looms that carry hundreds of circuits connecting dozens of control modules. A modern Golf Mk8 has more than 70 separate electronic control units managing everything from engine fueling to lane departure warnings to over-the-air software updates. The electrical architecture in a current generation VW is more complex by number of discrete computing tasks than the avionics suite of a commercial aircraft from 15 years ago. Running that software through final calibration and sign-off is its own production stage, and it takes longer than most people would expect. Every 16 seconds, another car moves from one assembly station to the next. The line does not wait. End-of-line testing is where every car earns its release. No car built at Wolfsburg ships without passing a sequence of tests that would have been considered extreme quality control even 30 years ago. The car goes onto a roller dynamometer. Rollers built into the floor spin the wheels at road speed, while the test system runs the drivetrain through a full load cycle, checks brake response, confirms that the engine hits its torque and power targets. Headlights go into an optical alignment rig. Every headlight aimed, every beam pattern confirmed. Then the rain tunnel. The car moves through a chamber that fires water at it from dozens of angles simultaneously, replicating the pressure of a serious downpour, then checking every door seal, every window gasket, every body joint for any sign of water ingress. One drop in the wrong place, and the car comes off the line. A full digital interrogation follows. Every control module in the car queried simultaneously. Error codes logged, software versions verified. And for any model carrying advanced driver assistance systems, the radar and camera sensors get a dedicated calibration pass, confirming that the system's spatial references match the actual geometry of that specific vehicle. The car that was raw coiled steel at the start of all this now holds a digital test certificate. Every parameter, mechanical, electrical, structural, optical, logged against the vehicle identification number that will follow it for the rest of its life. Here is something almost nobody thinks about when they buy a Volkswagen. The electricity that built it, the power running every press, every laser welder, every paint oven, every robot, did not come from the grid. Volkswagen operates its own power stations at Wolfsburg. The West plant generates 288 megawatts. The North plant generates 133 megawatts. Combined, those stations do not just power the Wolfsburg factory. They supply electricity to VW's factories in Emden, Hanover, Kassel, Brunswick, and Salzgitter. And they supply district heating, the piped hot water that heats homes and apartments to the entire city of Wolfsburg. The factory that created the city now keeps the city warm. By the end of 2021, Volkswagen completed a $400 million conversion of those plants from coal to natural gas, eliminating coal combustion from the site entirely. Since the day this factory first built a Beetle from bombed-out rubble in 1945, approximately 45 million cars have been assembled at Wolfsburg. 45 million. A fair number of those have been Golfs. 37 million Golfs built since 1974, across 8 generations, making it the third best-selling car in automotive history. Europe's best-selling car for 14 consecutive years, from 2007 through 2021. In 2023, Volkswagen Group, the parent company that also owns Audi, Porsche, Seat, Skoda, Lamborghini, Bentley, and others, produced 9.31 million vehicles worldwide. China alone accounted for 2.93 million units in 2024, making it the single largest market VW serves. The scale of what happens in Wolfsburg every day is not impressive in isolation. Every car company in the world has studied it, copied it, and built on it. Platform sharing, takt-time discipline, just-in-time supply chains, the digital test certificate, Wolfsburg pushed all of them to an industrial extreme that forced every other car maker to respond or fall behind. Every 16 seconds since before most of us were born, and yet the factory now faces its most consequential reinvention since Major Hurst switched the line back on after the war. The model coming is called Trinity, Volkswagen's next flagship electric vehicle, built on the new SSP platform. The Scalable Systems platform is slated to enter production in Wolfsburg around 2026. The ambition is not modest. Trinity is meant to be VW's answer to Tesla's manufacturing philosophy: extreme automation, software-defined architecture, over-the-air updates that can change how the car drives years after it leaves the factory. The target assembly time is 10 hours. Current Golf production runs at roughly 30. Getting from 30 to 10 means rethinking almost everything about how the assembly hall is organized. Meanwhile, in Foshan, China, Volkswagen's joint venture plant has already built the model Wolfsburg is chasing. Over 1,200 robots in the body shop alone, paint shop automation running at nearly 100%, 200,000 square meters of solar panels on the roof, enough to run the facility on fully renewable energy, and crucially, the Foshan plant already runs 2 platforms side by side, MQB for gasoline models, MBB for battery electric vehicles, on the same production line. What Trinity needs Wolfsburg to do, Foshan is already doing, at Chinese labor costs, with Chinese supply chain density, 2 kilometers from the world's most competitive battery suppliers. That is the question hanging over every one of those 16-second intervals right now. Can a factory city in Lower Saxony, built by the Nazis, rebuilt by a British army officer, scaled into the industrial spine of the German economy, reinvent itself fast enough to compete with what is happening in Shenzhen and Shanghai? Can 62,000 workers and 11,500 engineers keep pace with a country building gigafactories the way Wolfsburg once built Beetles? Can the Trinity platform carry Wolfsburg through another 80 years, or does the rhythm, 1 car every 16 seconds, belong to a world that is already passing? Nobody outside the glass towers of Wolfsburg headquarters knows the answer yet, but the history of this factory suggests you should not bet against it. From a flat floodplain in Lower Saxony, from a savings fraud and slave labor and British Army field improvisation, from the wreckage of the worst war in human history, 1 car every 16 seconds, here is what I want you to drop in the comments. Do you think the Trinity EV platform gives Wolfsburg a genuine shot at matching the Chinese gigafactories? Or is Germany's cost structure, its union contracts, its grid limitations, simply too much to overcome? I want your honest take. If this gave you a new angle on something you thought you already understood, hit the like button and send it to one person who cares about where manufacturing is headed, because this conversation matters well beyond the car industry. Make sure you are subscribed, because the next video goes inside a factory where the raw material is not steel but sand, and what comes out the other end powers every device on the planet. 1 every 16 seconds. Even now, as you read this, the line is still moving.